So in 5.1, we're still dealing with our trig functions. We're just using them a different way here. We're going to use trig identities to simplify trig functions and come up with a new one. So here we have our identities. The reciprocal identities you guys should know already. So like sine is 1 over cosecant. Cosine is 1 over secant. Tangent's 1 over cotangent. And then cosecant is 1 over sine. So these 6 you guys should know already. They're our reciprocal identities. We have the quotient identities, which tangent is equal to sine over cosine. Tangent, we know if we were talking in terms of like x, y, and r, tangent's y over x, which sine is our y and cosine is our x. So that's how we get that tangent is sine over cosine. And then cotangent is cosine over sine. The Pythagorean identities, these will be given to you, so you don't have to memorize these. I'll give you these on the quiz. But usually anytime you have something that's squared, you're going to want to use your Pythagorean identities to simplify. Especially if you have something that's like squared plus 1. Now your cofunction identities and even and odd identities, these won't be on the quiz. There might be 1 or 2 questions on the homework that you can use these for. So just look back at the notes if you have a question like this. But you're not going to be tested or quizzed on these, so you can just skip them. But if you do have a question on the homework where it looks like one of these, just look back at this chart here and it'll answer your question. Looking at example 1, it says use identities to evaluate a trig function. This is exactly like we were doing in chapter 4. Secant, in terms of x, y, and r, is what over what? R over x. So secant goes with cosine, so it's the reciprocal of cosine, which would be x over r, so our reciprocal is r over x. So 3 would be our r and 2 would be our x. Where would the negative go? With the 2, because r is always positive. Perfect. So it'd be -2 is our x. How would we find the y? Pythagorean theorem. We're going to skip this example just because it's exactly like we've been doing. You guys know how to do this. So example 2 is the new stuff. We're going to be simplifying our trig expression. So here we have 2 terms. We've got sine of x times cosine squared minus sine of x. So terms are separated by a plus or minus. We've got 2 terms here. Do we have anything in common in these 2 terms? Sine of x. So I can pull out my GCF, which is sine of x. So this is just algebra. We're simplifying using algebra. If we take out a sine of x, what are we left with? Cosine squared x minus 1. Perfect. Now, like I said before, whenever we have a trig function squared, especially if it's attached to a 1, we're going to use our Pythagorean identities. So I'm going to copy and paste our Pythagorean identities here so we can see it. So we have cosine squared minus 1. I want to make one of these identities look like cosine squared minus 1. So I'm going to use the one that's involving cosine. What do you think I could do to this equation to make it cosine squared minus 1? How could I rearrange this to make it cosine squared minus 1? We're just going to move everything around. So I'm going to subtract 1 on both sides. So now I have sine squared plus cosine squared minus 1 equals 0. But I want it to just be cosine squared minus 1. What else would I have to do? Subtract the sine squared. So now we have cosine squared minus 1 equals negative sine squared. So I'm going to take this cosine squared minus 1 and replace it with what? What did we say cosine squared minus 1 is equal to? Negative sine squared x. And then we're still multiplying that by sine of x. What do you think sine times sine squared would be? Awesome. Negative sign to the third power. So this would be our answer. This is as simplified as we can go. Our goal is to try to simplify this to just be one term if possible. Sometimes it'll be like a sine times cosine where you can't simplify anymore, but our goal is to get it just to be one term. So in order to use our identity to get it to be simplified, we needed to make it exactly the same. So I needed to make it cosine squared minus 1. So that's why I rearranged it to be cosine squared minus 1, so I could just plug in the sine squared, or negative sine squared. So these are different. There's not like solving, even though we're using our algebra skills to try to simplify, it's a little bit different than what we've been doing. It's kind of like solving a puzzle to get it to simplify. Some people see it right away, some don't see it right off the bat, so it's super important that you guys practice these. So it's different, it takes practice. Let's look at example 3. So example 3 says factor each expression. So for A, we have secant squared theta minus 1. Now it doesn't matter if it's a theta or an x. Sometimes you'll see t as your variable. The variable doesn't matter. It's just the trig function. How do you think we could factor this? Close, but if I were to replace the secant with an x, if I had x squared minus 1, how would I factor this? X minus 1, x plus 1. It's the difference of squares. So same idea here, it's a difference of squares, but what do you think it would factor to? Secant theta minus 1, secant theta plus 1. Perfect. So here we're not really simplifying, we're just factoring. It told us in the directions just to factor, so this would be our answer factored. Now looking at B, same thing here, we want to factor. If this had x's, let's say it was 4 times x squared plus x minus 3, how would I factor this? A times c, we multiply the first times the last. So same idea here, we're going to multiply the first times the last. We get negative 12. What are two factors of negative 12 that add to 1? 4, negative 3. So instead of writing x plus 4 and x minus 3, it's tangent here. So I'm going to say tangent of theta plus 4 and tangent theta minus 3. Now, because we started with multiplying, what do we have to remember to do? Don't forget to divide by that 4. So we're going to divide our numbers by 4. Simplify if you can. So this would be tangent theta plus 1. If it doesn't simplify, where do we put it? In front of that tangent. So it would be 4 tangent theta minus 3. So this would be factored. So it's the same as algebra. We're just factoring like normal, but instead of having x's, we just have our trig function. So same thing here, it says to factor, but in order to factor, they have to be the same trig function. So it needs to be the same trig function in order to factor. So we have identities for when we have a trig function squared. I'm going to see if I can replace my cosecant squared using one of our identities. What does cosecant squared equal? 1 plus cotangent squared. So cosecant squared is equal to 1 plus cotangent squared. So I'm going to replace cosecant squared with 1 plus cotangent squared. So we have 1 plus cotangent squared minus cotangent minus 3. What do you think I would need to do next to factor? Combine like terms. What's 1 minus 3? Awesome. So we have cotangent squared minus cotangent minus 2. Here we can just factor like normal. What are two factors of negative 2 that add to negative 1? negative 2 and 1. So how would this factor? What would we write? How would we write our answer? Cotangent x minus 2 and cotangent x plus 1. Perfect. That would be our answer. All right, looking at example 5. Here we're simplifying. So sometimes when you're given a bunch of different trig functions, it's going to be easiest to put them in terms of sine and cosine. So I have a sine of t. I'm going to call it x instead of t just because t's look like plus signs. So I'm just going to make these x. So sine of x plus cotangent of x times cosine of x. Now the only one that's not in terms of sine and cosine is cotangent. How could I make cotangent in terms of sine and cosine? Look at your identities. I can make it cosine over sine. So I'm going to replace the cotangent with cosine over sine. Now hopefully I can combine some things together to simplify. I can multiply these two together. If it was cosine over 1, what's cosine times cosine? Cosine squared. So I'm going to make it cosine squared over sine of x. And then we're still adding that sine of x out front. If I want to combine these together, again, my goal is to try to combine this just to be one trig function. What do I need when I'm adding with fractions? Common denominator. So I could make it sine over 1. What would my common denominator need to be? Sine. So I'm going to multiply the top and the bottom here by sine. So I get sine squared over sine plus cosine squared over sine. Now can I add these together? Yes. Yeah, we get sine squared plus cosine squared over sine. Now again, when you have squareds, you want to think your Pythagorean identities. What's sine squared plus cosine squared looking at our Pythagorean identities? Sine squared plus cosine squared is 1. So I'm going to replace the sine squared with cosine squared with 1. You'll have your Pythagorean identities, yeah. Just that one. If it's 1 over sine, what could we flip this to? Cosecant. So this would be cosecant. So all of that work, and we simplified it just to be cosecant. So for this one, we used our reciprocal identities because we knew that 1 over sine is cosecant. All right, last one, example 6. So we have 1 over 1 plus sine. It says to rewrite it so that it's not in fraction form. So this one's a little bit funky, but we're going to use a lot of strategies here that you will see throughout like different simplifying ones. So whenever we want to write something not in fraction form, make it not a fraction anymore, we can multiply by the conjugate. Anybody know what our conjugate is? 1 minus sine x. Perfect. So we're multiplying by the conjugate of the denominator, so we have to multiply that to the top and the bottom. So on top, we just have 1 minus sine x, because when we multiply that times 1, it's the same thing. In the denominator, you can use your conjugate shortcut, or just FOIL. Either way works. So our conjugate shortcut is a squared minus b squared. So our a would be 1, so 1 squared minus our b is sine squared. And what's 1 squared? Just 1. So 1 minus sine squared. Now when we have a squared trig function, especially when it's attached to 1, we want to use our Pythagorean identities. So I'm going to copy that box here again. So what could I change 1 minus sine squared to be? So we're going to use our one that has sine squared here. How could I make this 1 minus sine squared? What would we need to do? Subtract sine squared. So we get cosine squared equals 1 minus sine squared. So I'm going to replace the 1 minus sine squared with what? Cosine squared. I'm going to rewrite this so it looks a little bit neater. So we have 1 minus sine of x over cosine squared x. All right, so we used our Pythagorean identities, but it's still a fraction. We need to make it not a fraction. So pay attention to what I'm going to do here. I'm going to split this up, but when I'm splitting it up and I'm subtracting, if I'm adding or subtracting, in order to combine fractions together when you're adding or subtracting, you need a common denominator. So my denominator is going to stay the same when I split these up. So I have 1 over cosine squared minus sine over cosine squared. So if I were to subtract these two fractions, since I have a common denominator, I would end up with this. So these are the same. The top one's just a little bit more simplified, but our goal is to not really simplify, it's to get rid of the fraction. So just like in that last question we had, when we had 1 over sine, we made it cosecant. I could do the same thing with the 1 over cosine squared. I could use my reciprocal identities. How would I change 1 over cosine? It'd be secant. But instead of just secant, since it's cosine squared, it would be secant squared. So we will change this to be secant squared. So we're going to use our reciprocal identities. 1 over cosine squared is the same as secant squared. Now with this one, we have a little bit more work to do. So we still need to make this not a fraction. Now I'm going to split this up, but pay attention to the difference of when I just split it up when I was subtracting, what I'm going to do now. So in order to split this up, I'm going to split it up with multiplication. So I'm going to make it 1 over cosine x times sine of x over cosine x. So here I split it up with multiplication. So if I were to multiply these two together, I would end up with sine of x over cosine squared. So notice how in that first step when I split them up, they both got the same denominator. In the second step, I'm splitting the denominator with it. So when you split it with multiplication, the denominator doesn't stay the same. You got to split the denominator too. So these are different. Notice the difference between the two. Now here I'm multiplying these. What does 1 over cosine simplify to? Secant, perfect. So I still have that secant squared from before. 1 over cosine is secant. What does sine over cosine simplify to? Just tangent. So times tangent. So this one changed to be secant and this one changed to be tangent. Do I have any fractions anymore? No. You can simplify this a little bit. We have a secant in common, so if you wanted to take out the GCF of the secant, but it's really not going to do anything to like make it more simplified. The goal here wasn't really to like simplify, it was just to get rid of the fractions. So this question involves a lot of the different strategies that you're going to use to simplify, but it kind of just puts it all in one question. So you need to know, this is just a lot of algebra simplifying here. You need to know how to split it up when you're subtracting, or the difference between splitting it up with multiplication. You need to use your reciprocal identities, use your Pythagorean identities. So this is a lot in one question. This one I would say is a challenging one, but it's good to show you all the different strategies to help